Assalamualaikum. We from Group 1 present our foundation design project for the interchange bridge. Those in our group are Brandon Shashi David, Nuridah binti Samakun, Muhammad Nazmi bin Abu Bakar, Nur Falidiawati binti Nur Tahir, Muhammad Zaki bin Sudi Hamzah, Syahminawi bin Yasin Aminullah, Nihayah binti Muhammad Zain, Muhammad Hafizi bin Ismail and Wahidah binti Hashim. Our group member, Wahidah, will be the first to start.
Table contents. This is the table contents in our group project. Introduction, project background, company background, organization chart, objective, method field and testing, soil profile, foundation design and calculation, retaining structure design calculation, and conclusion. Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Wahidah binti Haji Hashim. Today I would like to present about foundation design project. Introduction. Geotechnical engineering students soil behavior under loads and soil water interaction. Applying this knowledge to design foundation, retention wall, earth dam and waste containment system. Geotechnical engineer conduct field and lab investigation to determine soil property for various construction projects. The process begins with assessing site material and conditions to design suitable foundation and structure like high-rise building, bridge, dam and tunnel. Okay, below this picture show you about construction project. Next, project background. This project is to design a foundation for the interchange bridge. Bridge description: vertical load 8,000 kN, horizontal force 400 kN, surcharge behind abutment 20 kN per meter square. Foundation suggestion by foundation. This is a picture construction project, column construction, wide view and bright side elevation view. Last with me but not least, company background. Safal Consultant Sendirian Berhad. Mission: to carry out engineering and development tasks with a focus on cost control and outstanding quality, and every area took a piece strict efficiency, on-time delivery, safety, and environmental requirement. Next, the vision by providing projects that are complying with international standards for project engineering, management, construction, and maintenance. The company will be work to become to top multidiscipline engineering company in Malaysia.
Next, I will introduce our organization chart. Firstly is our director, Mr. Nazmi, where he need to ensure business operation are implemented based on the company policy. Next, the technical engineer, Mr. Hafizi, where he need to gathering and analyzing the data by monitoring during and after construction to make sure the structure is stable. Next is site operation manager is Mrs. Nuridah, where she need to prepare the staff work schedule and assign by specific duty. Next, site coordinator, Mr. Zaki, where he need to training other team member on the test method are required. Next, site safety supervisor, Mr. Brandon, where he need to make sure all the site workplace are safe for all the team, all the site team. Next is QA/QC manager, Mrs. Nur Falidiawati, where you need to ensure all the documentation quality control is compliant and complete as book handover through the QC turnover engineer. Next is drafter, our Mr. Shaminawi, where you need to design the product with the engineering and manufacturing technique by the specification created by engineer. Next, laboratory manager, Mrs. Wahidah, where you need to manage and maintain the laboratory facilities to ensure safe and production environment. Lastly is me, lab technician and chemist Nihaya, where I need to test and analyze sample to determine their content and characteristic using laboratory tools and test equipment. Next, we have a 4 objective for this foundation design. Firstly is to define and distribute the weight of the structure over a larger area of soil. Second, to make sure and avoid unequal settlement Third, to know the condition of soil to prevent the lateral movement of the structure. And lastly, to increase the structure stability.
Method and field testing. Field exploration. The initial stage of this project involved assessing the rock or soil that will support the structures. Factors like the project schedule, subsurface condition, and load requirements influence the extent of site investigation. The main goal of field exploration are to gather as much information as possible about the proposed construction area, such as the properties of the soil, existing nearby structure. Soil exploration is a part of field exploration. Soil exploration is a crucial field activity that investigates subsurface soil features, content, and structure at a proposed project site. The aim is to gather comprehensive information about soil characteristics, including composition, density, moisture content, strength, and load-bearing capacity. This knowledge facilitates informed decision during project planning and foundation design. The stage soil exploration consists of site reconnaissance, preliminary exploration, and detailed exploration. Method of soil exploration. Every soil exploration approach has unique benefits and drawbacks, and to fully assess the qualities of the soil, a mix of this method is frequently used. First, subsurface soundings, methods such as cone penetration test (CPT) and standard penetration test (SPT). Second is exploratory drillings. This type of soil exploration entails drilling into the ground to collect soil sample and obtain data regarding condition beneath the surface. Soil sampling, split spoon sampler, which have attachment like flag retainers for cohesive soil type, were used to collect disturbed sample. For the undisturbed sample, a 50 mm diameter thin wall tube sampler were used. The rotary drilling was used to drill the borehole 1 and borehole 2. In this soil investigation, an in situ field test called the standard penetration test or SPT is used to determine the different geotechnical engineering qualities of subsurface soil, particularly cohesive soil. Finding the various characteristics and parameters of the soil that show its strength is the aim of the SPT test, which depend on the number of SPT or SPTN. From the SPTN number, we can do a correlation to get some soil characteristic or properties. The unit weight, relative density, angle of internal friction, and undrained compressive strength may be estimated based on the SPTN number.
This is a soil profile for two boreholes, borehole 1 and borehole 2. The legend explains the symbols used to represent different soil types. The boreholes also include SPTN values, which are a measure of the relative density of the soil. The groundwater level is also indicated for each borehole. By analyzing all of this information, engineer can interpret the subsurface condition at site. This information is important for foundation design and others geotechnical engineering project. Details that you can see from the soil profile. The soil profile is described down to a depth 22 meter for borehole 1 and 18 meter for borehole 2. The soil types accounted include sandy, silty, clayey, sand. Each layer is color coded and labeled with its representative depth in meters. Different soil types have different engineering properties such as strength and permeability. Understanding the soil type at site is important for designing safe and stable structure. Borehole 1 shows the first 5 meter depth is soft layers and the SPTN value is 3 to 4, and for borehole 2 is only 1.5 meter depth soft layer. The SPTN values show is 4. Higher SPTN value is indicate denser, stronger soil, and lowest value indicate looser and weaker soil. This information is important for determining the bearing capacity of the soil, which is the ability of the soil to support a load. Borehole 1 show the layer of rock at depth 16.5 meter to end of borehole 1 at 22 meter. The legend indicates this rock layer is granite with good rock quality designation. The ground level is encountered at depth of 3.2 meter in borehole 1 and 2.8 meter in borehole 2. The presence of groundwater can affect the stability of slopes and excavation, and it can also be corrosive to some foundation materials. Understanding the groundwater level at site is important for design foundation and other structures.
Assalamualaikum, my name is Norida. Based on the soil profile, our group decided to design for a profile. I will provide the design calculation for borehole number 1. The termination depth is 16 meters and ends at the clear layer. The diameter of the pile is 0.75 meter. We wish combination A2 plus N1 plus R4. The material properties values is shown in the slide. Firstly, we design for as an individual pile. It is necessary to draw the stretch diagram to calculate shaft resistance in sand. L front is 11.5 meter. Since the sand layer is 6 meter thick, the stretch 5.25 meter into the clay is ignored. By applying partial factor on shaft resistance, the design shaft resistance is 434.14 kN. Then, by applying partial factor on base resistance, the design base resistance is 344.74 kN and comprehensive resistance is 782.87 kN. We check by applying combined or global partial factor to the characteristic of shaft resistance and base resistance, we get 695.24 kN. Total load to be carried by column 8,400 km. Individual pile is not capable to carry the load, and then we design for group pile. For the group pile, we try using 15 core piles with a spacing of 2.25 meter. By applying partial factor on base resistance, the design base resistance for a group pile is 4826.30 kN. Then, we calculate for shaft resistance. By applying partial factor on shaft resistance, the design shaft resistance is 12621.56 kN and comprehensive resistance is 17447.86 kN. Check by applying combined or global partial factor to the characteristic of shaft resistance and base resistance, we get 14923.55 kN. Compare between the group and summation of 15 individual parts, take the smaller value, which is 10428.67 kN to represent the pile group capacity. This value is greater than 8,400 kN, so the design is passed. Finally, we check for the settlement of the design pile. We get the total settlement is 38 cm, which is exceed the allowable settlement. The allowable settlement is 50 mm. Here's our justification. According to table 1.1, termination depth for bridge construction requires a minimum of 50 meters or 7 consecutive and equal to 50. Data for borehole number 1 is only collected until 22 meter with only 1 consecutive and equal to 50. This explains why the settlement computation for this group pile is failed. Borehole data for design interchange bridge is insufficient. Additionally, the pile depth must be increased to meet the allowable settlement.
From our soil profile for BH2, we decide to design for friction pile, bow pile, which is the termination depth is 16 meter and the settlement is at the sand layer. And next is show how we calculate the calculation. The first step is we find the material properties. And the next step, we calculate pile as individual pile and then we find the shaft resistance. And the next step, we apply partial factor of shaft resistance to design shaft resistance. The next step, we calculate base resistance. We refer table 3.2 Public Work Department 2016. After that, we find characteristic base resistance of pi in clay. And then we applying partial factor on base resistance, the design base resistance. And then we check by applying combined or global partial factor to the characteristic RBK and RSK. And we compare the two value of RCD and take the smaller value. Total load to be carried by column is 8,400 km. Individual pi is not capable to carry the load. Then we design for group pi. After that, we calculate group pi. We use 15 numbers pi with 3D spacing. And then we calculate base resistance, the width and length of the block, plan view as a figure 1. After that, we applying partial factor on base resistance, the design base resistance. And after that, we calculate shaft resistance, which is we find the total of RSG, and then we apply partial factor on shaft resistance, the design shaft resistance, and comparing the two value of RGD and RSG, the total load that can be carried by the pi group is 10,184 and 55 kN. Therefore, is more bigger than 8,400 kN, and the result is okay. And then we check the settlement of pile BH2. For pile in sand, consolidation settlement can be estimated using the following expression from the US Navy Department of Navy 1982. In this situation, no field tests have been conducted for the single pile. Hence, the load settlement curve cannot be plotted. So, settlement calculation for these piles cannot be calculated.
Hi, my name is Mazaki, and now I will explain regarding our returning wall design. So, as you can see, we already split into our design into 3 dimension, which is for the beam and wall, and this one is for the load that we will use for this calculation. As you can see, we already collect all the data from the figure below, which is we can know the L is 6.5 meter, the F is 1.4 meter, D is 1.10 meter, and the total height is 9 meter. And then for the HFD is 0.75 meter, and for B1 for the base is 2.5 meter, 0.7 and 3.5 meter, which is we already split into the 3, and the total B is 6.75. And other than that, we already get the data from the table 8.3, 8.4 and 8.5 in the Geotechnic 2 books, which is gamma G, gamma theta and gamma gamma and gamma Q is 1.35, 1.0, 1.0 and 1.5. And then we already calculate for gamma concrete, which is 24 kilonewton, and the C is 0. And other than that, we already got for the tangent is 0.3639. And then we already got the calculation for the KA, which is KA we already got from the graph coefficient C.1.2, which is in the Geotechnic group, Geotechnic book 2. And for the KP is also from the graph coefficient C.2.1, which is also in the same books. And then we already correct for PAH1, PHD1, PAB1, PAH2, PHD2, PAB2, which is we already calculate using the formula in the books Geotechnic 2, which is the answer we can get from the table below.
Assalamualaikum and hi, I'm Syahmin Abi. I will continue in presenting regarding the returning wall design. So the theta D is 30 with the calculation of inverse tangent times tangent 30 divided with the partial factor, and then CD is 0, delta D is 20, gamma D was the gamma divided with the factor, which is 1.0. The total is 18 kN per meter cube. And then we move forward to the total pressure force. The equation was 1/2 times with gamma D, gamma soil, and then time with the F plus D equal power of 2, and then time with the PhD1. So we got here is 281.25 kN per meter. Then we move forward to the design destabilization moment. For the MOT1, moment 1, the equation was PhD1 times 1/3 times moment arm. The total is at 126.686 kN per meter. For the moment 2, the equation was PhD2 times 1/2 times moment arm. The total was 340.2 kN per meter. Next, we need to do the table as shown in the slide. So we need to find the area of the structure and soil, and then we find the force. Force is the area times with the unit weight density. Then we find the design force. Design force is the force divided with the partial factor, and then we find the midpoint of the structure. For the moment arm measured from X, then we find the moment kilonewton per meter from the X is which equation with design force times with the moment arm measured from X. After that, we find the traffic load as given in the question. Then we find the pressure PAV1 and PAV2 stated. We put the force, and then we find the design force and moment arm and the moment arm, and then we find the passive force. We put inside the passive force, and then the total moment that we get is the 4,300, 04 and 82. After that, we find the design factor against overturning. So the equation was is design resisting moment divided with design overturning moment. For 304.283 divided with 1166.886. So the total answer is 3.6892, more than 2, which is okay. And then lastly, we go find the design factor against sliding. So the equation was the total RD times with tangent 20 plus with base length times with the soil cohesion plus with the passive pressure 1 and 2, and then divide with the PhD1 plus PhD2. So the answer is 1.7257, which is more than 1.5. As that this one is we take the criteria based on the TKR geotechnical design criteria for road project.
Good day to everyone and Selamat Sejahtera. Firstly, I want to express my heartfelt gratitude to my fellow groupmates for their incredible efforts and dedication. Their presentation have clearly demonstrated our collective commitment to excellence. Based on the JKR geotechnical design criteria for road projects, we have confirmed that our retaining wall design is highly satisfactory. Our analysis show an overturning factor of 3.6892, well above the acceptable threshold of 2, indicating strong stability against overturning. Additionally, our sliding factor of 1.7257 exceeds the required minimum of 1.6, ensuring the wall is stable against sliding. In our foundation design for the proposed bridge using the SPTN approach, we analyzed the data from borehole 1 and borehole 2. Both boreholes use a 15-pile group design in either clayey or silty sand. For borehole 1 ending in clay at 22 meters, we found a group pile capacity of 10,428.67 kilonewtons, significantly above the required 8,400 kilonewtons. Similarly, borehole 2 ending in sand at 18.16 meters showed a capacity of 10,148.55 kilonewtons, also exceeding the requirements. These results show consistent despite different soil conditions, validate the strength and reliability of our design approach. In conclusion, our retaining wall and foundation designs are structurally sound, safe, reliable, and ensuring the long-term stability and performance of the proposed bridge. Thank you all for your exceptional work and contributions. Thank you.